So I decided to give a go at pulling out my 386DX processor out of my 386DX PCB that I've been building, or PCBs, and try a 486 DLC processor. And a little bit about this processor as far as how I understand it. First, it's pin compatible with the 386DX. So in theory, I should be able to just pull my 386DX and drop in the 486 DLC, and it should work. Another comment about the drop-in off to the right on this, you'll see some of these pins denoted with a single asterisk. And if you see that, those are pins that are exposing signals related to the internal cache, which is a bullet I've listed on the left, is there's a 1K cache in this processor. Now on the 386, those were no connect NC pins, so I don't have those anywhere in my schematic. If at some point I do want to leverage those, I'll have to tap into them from the bottom of the socket. But I don't think I'm going to use them. But I'll need to learn more about the cache and what those signals are used for. Maybe continuing to talk about the cache, it is disabled by default, and I'm going to leave it disabled for now. And that can be modified by writing and reading an I/O, basically an I/O address of 22 and 23 to get to some registers to control the behavior of the cache of the processor. So at some point my BIOS will have to be updated so that on boot it can access those I/O addresses of 22 and 23 and enable the cache if that's going to work in my hardware setup, which I don't know if that will or won't yet at this point. Maybe another nice note about this processor, it is fully static, which means I can run it really slowly. I can also completely pause or stop the clock and then resume it. So that is nice for me and my debugging of this system that I've been working on. Something else about this processor, they mention, and this would be Cyrix mentions that it has fast I/O. And what they claim is that the processor can continue processing during I/O functions, and that might improve things that are I/O intensive, maybe video or disk performance, or some other type of I/O task. With this, I also get access to any new instructions in the 486 instruction set, and this processor supports the coprocessor that I already have, at least in my board. I have not, in the schematic of my board, the design of it, I have not installed a socket or put it in yet. In theory, this 486 DLC should be able to take advantage of the 387DX that's already in my design. So with that, maybe what I'll do is I'll flip over here to my system, and I am recording the TerraTerm debug output, which is going to come out of this chip here, this little nano, to my PC. And I'm also recording the VGA output. So let me go ahead and turn this on, and then I'll talk through a few more things about a couple things I ran into as I tried to get this up and running. So some things to note on the TerraTerm output, it's outputting the stuff that I expect. I'm doing some SPI initialization, and during that I write out to the through SPI to this debug nano to write to the PC, and that's where I'm writing out that I'm initializing SPI, and then this string about what my system is currently running at. Plus on the VGA output, I clear the VGA memory, and then I put a little logo in the upper right, and then some similar type of details, what BIOS version and what speed I'm running, things like that. And then I can come in here and I can use my fancy little keyboard here and type in hello world. So all of that is working. Now, it was not just a plug and play though, so I wanted to talk through a couple of things that I did to get this working. In the end, it wasn't necessarily a real big deal, but it was something that I did have to put a little bit of time into just to track down. When I first put in the 486 and I turned it on, it really did not work, and I ended up having to do a few things, but probably the first thing I did is I dropped my clock speed down. So I went from a 24 megahertz clock 2 down to a 24 megahertz, I went from a 24 megahertz clock 2 down to a 12 megahertz clock 2. And then the system would boot up. And I would get to my VGA screen and the initial serial output, and that all looked fine. But then I also noticed that interrupts did not work. So none of the interrupt processing was working quite right. So those were the issues I had to deal with. And what I ended up doing along the way is I did come into some of the ICs and changed the family. So I went from, for example, an HC to an ACT on my data receivers or transceivers. So on the data transceivers, I went to an ACT. And that made a big difference. And I also have address latches, and there's also a pair of control latches. And I did have to swap out one of my control latches. And actually, I ended up putting an HC in there. So again, I know I'm mixing and matching and probably doing some things that need a little bit more analysis and thought on my part, and I'll get to that. I'm working on that slowly and just have to better research that. And I like to experiment too and just see what happens when I use different families, what behavior I get. But anyways, I did a little bit of experimenting with that and found some things that improved it. I also came into my PSOC here and I added a little switch. And there is a spot on the PSOC to actually mount a switch, but I wanted to use a certain pin because I've already used many of these pins for certain things. And if I pull up my design for that PSOC real quick, all I did is I have this switch running to ground, and that lets me, and it internally is set as a pull-up. So I took a pin, input pin, I set it as a pull-up by default, and then I have a switch that takes it to ground. And so if I flip it, I can ground it, or I can just let it stay high. But that's going to let me pick internally within the PSOC, am I going to run my main clock 2 at 12 megahertz or 24? And this basically flows on through, and that's where I get out to my clock 2 output. Really, it's going to take one of these, either the 12 or the 24, depending on where I have that switched. And then as a reminder, when my system first initializes, I start with a 100 hertz clock just for a little bit. And then it seems once the system gets going, then I can fire it up to 24 and I don't have any issues. And I've not spent time to try to track down why I need to start with a slow clock yet. And that'll come at some point when I find time and energy for that. But I can switch between a 12 and a 24. That generates my 12 or 24 clock 2. Half of that goes out to my clock. My VIA, I'm going to run an inverted CLK. And then I also have this peripheral clock, or P clock, which is half of it again. So I've got if I'm running at full speed, 24 megahertz clock 2, 12 megahertz clock and VIA clock, and then a 6 megahertz peripheral clock. Another issue I did have, though, and the reason I put the switch in, maybe to pause for a second, is so that I could easily drop it down to half speed and run 12 megahertz into my processor, 6 megahertz on the ISA bus, and just do testing. And then when I wanted to, I could flip the switch and go back to what I'm considering full speed for this system. And I didn't have to keep reprogramming the PSOC, and I didn't have to use that external, this little type of clock card that I've been using in the past. So this is working really well, that little switch. But as I was going through that, I would notice I could do things at the 12 megahertz fine, but it would fail at 24 with this processor. Now, if I put the 386 in, everything was running fine with the full 24 megahertz. But something wasn't quite right. So what I ended up doing is I put some pull-ups on all the clock lines. So those clock 2 clock and then the peripheral clock, I put a 1.8K pull-up on each of those lines. And that took care of the issue. So something with this processor and my clock signal getting to it, it's fussier than the 386 was. And it's probably because internally it's trying to run at 24 instead of running at 12, half of the clock before. So it just means I probably had to have a cleaner, something a little bit better on my clock that was getting to that processor. And that pull-up probably isn't the root cause fix, but at least addressed the issue well enough for now. In the future, I need to put little resistors in line with these clock outs because I don't have that. Plus, I should have pull-ups available to do some of this type of optimization. So I put in the switch for debugging. I put in the 3 pull-ups. And things are working. So again, if I go back to this, I'm running 24 megahertz into the processor internally then is running 24. My pretty much rest of system, so my ISA clock, the CLK on the ISA bus is running at 12 megahertz. My VIA up here is running at 12 megahertz. And that's pretty much it. So pretty much everything's running at 12 except for the processor is internally running at 24. And so far, things seem to be working. Now, I don't know what it's going to look like after I get another card plugged in, like an IDE interface card. So I've got to get that figured out. I still need to come in and put in my math coprocessor, so that'll hopefully be something I can get done in the next month or two. I'd like to have that coprocessor up and running if it's going to work in this system at least. But I'm feeling pretty good with the system right now. So I've got full 24 megahertz processor, 12 megahertz on the ISA bus, which is probably plenty fast for an ISA bus, especially considering I'm going through these Euro-DIN connectors. So I'm happy that 12 megahertz of all my signals coming through there has been fine. Amazingly, the logic that I have in my PSOCs, I really had to figure out how to generate all these signals based off of the hardware reference guide for the 386, how to generate S0 and S1 and all those other signals in my weight states. That's all carrying along just fine here at full 24 megahertz. Maybe as a reminder, these PSOCs, I can run 24 or I can run half of that. I can run 12. There's really no in between. Ideally, I'd like to run in between. 24 is maybe a little faster than I ultimately was expecting to go with this. If it continues to work fine, that's great. But if it doesn't, then I might have to figure out how to get an external crystal. There is a pin for me to put an external crystal on this, so maybe that is something I could do and find some other speeds besides 24 or 12 if it supports it. Or in the next version of this board, I will just put a few ICs on there to generate the clocks in the configuration I need and not do the clocks off of the PSOC just to give me more flexibility. But I think things are coming together. I'm happy and happily surprised with maybe where I'm at. Figured I'd run into a little bit more bodge work along the way, but I don't think I've got a whole lot on the back. I think I had pulled up a couple pads when I replaced a connector up here for a right angle connector. So I've got a couple little bodge wires for that. I had added power to these debug ports after I had the PCBs done, so I've got some wires for that. I've got some pull-ups. I've got the switch I've added, and then I have these enable signals for these address latches up here. But other than that, I don't think I have much for bodge wires. I don't think I've done any cutting on this board. So that for me is definitely, that's impressive for me. So I will take it. I'm not going to complain. And more to come in the next video. I think what I might do in the next video is take a look at some of the signals around the board, voltages, things like that, and just kind of share what I'm seeing. Again, I'm probably mixing and matching some chip families that I shouldn't be. I need to get my arms around that a bit better. I did get an update to my oscilloscope, so I updated it from 200 megahertz to a 350 megahertz scope. That was just a software upgrade, basically, to get that to happen. And I did get I ordered a couple of better probes for it. So I was using just the standard probes that came with it. They were 200 megahertz probes, just basic probes from Siglent. So I did order a 350 and a 500 megahertz probe just to see what kind of results I get with that instead. Obviously, if I'm going to run the scope at 350, I now need 350 probes, but we'll see what that does. And then in the last video too, I was kind of being lazy, and I had a little extension that I was clipped onto my ground, and knowing that was not a great thing, and one of you had called that out and just said, okay, that's probably causing some problems. So I'll do some measurements without any type of extra leads, or even go down to just the short spring clip that goes on the tip of the probe, just to really shorten up that ground path. And I'll try to show what I'm seeing for signals at different points on here, and then maybe looking for feedback of what looks okay and what What would you suggest is too messy that I need to try to do something better with? If anybody has any thoughts, suggestions on any of what you're seeing here, let me know. That's where I'm going to wrap up. So thanks for watching.